Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having a good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone, yes. Let me know fast in the chat box. Hello Prashant, hi Priyanka, hello Ashwarya, hi Tornado, hello Faisal, hello Piyush, hi Amir, welcome everyone, hi Mithun, hi Monisa. Welcome everyone, welcome. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not, yes? Yes guys, tomorrow we are going to take the complete revision for JEE 2021 students, right? Tomorrow I'll be starting at 11:30 sharp, right? And the session is going to be 5+ hours long, right? I'll try to complete your entire chemistry in that session, right? It's absolutely going to be your revision, proper revision is going to be in the form of the questions, yeah? Perfect, so do not miss that session tomorrow at 11:30 sharp, okay? So let me know fast in the chat box if I'm audible and visible to everyone, yes? Perfecto guys, yes, NEET aspirants can join it too, absolutely you guys can join in. No, it's going to be 10:30 AM, not PM guys. Yes, organic is there too, inorganic is there too, physical is there too, yeah? Perfecto guys, okay, so as you all must be knowing, tonight, it's going to be our 12th mock test of our complete chemistry, right? As I told you, I have told you in the earlier sessions that we'll be completing the 30 mock tests before your upcoming JEE 2020 examination, right? And out of those 30 mock tests, we are done with the 11 mock tests yet, okay? And now it's going to be the time for the 12th mock test to get killed right now in the tonight's session. Perfect. Okay guys, so the ones who are new to the channel, let me introduce myself. My name is Wassim Sir Vedantu and I'm your chemistry master tier writer on this JEE Enthuse English channel as well, yes. The ones who have not liked the video yet, please do like the video, share the video with your friends and do not forget to subscribe to the channel and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this JEE Enthuse channel, yeah. Perfect. So people, let me know in the chat box if you guys are super duper excited for the session, right? Let me know fast if you guys are super duper excited about the session. Let me know fast with some thumbs ups, yeah? Let me know fast with some thumbs ups. Yes. Perfect guys, perfect, wonderful. Wonderful guys, exactly. That's what I wanted, yeah? Alright, so people, let's get started with something called as Rank Booster JEE 2021 with complete chemistry mock test 12. And the first question for this mock test is going to be on your screen in 3, 2, 1, and now. Well, let me know the answer of this question, a very simple, basic and the ordinary question from your inorganic chemistry, right? Give it a try. Let me know its answer in the chat box. Which of the following is incorrect, right? You are given 4 options. You need to tell me which one of the following is incorrect among all. Give it a try and let me know. Hello Triambak, welcome to the session. Let me know its answer in the chat box. What do you guys think about this? Which one is incorrect? He's not saying which one is correct. He's saying which one is incorrect, right? Right? Let me know its answer in the chat box fast, yeah. Give it a try, let me know fast. I want every one of you to get involved in the chat box. Let me know fast in the chat box what its answer is going to be, yeah. Well, I'm getting only option B's and option C's, is that? Yeah. So people, let's give it a try. Let's see how this sort of equation is to be solved. A very simple and basic equation, I must say, yeah. Perfect. Which of the following is incorrect, right? First of all, let me tell you some basic things about it. See, if you talk about the ionization energy, how do we define the term ionization energy first of all? Ionization energy is basically, it is the amount of energy which is required to knock out the electron, which is required to knock out the outermost electron from the isolated gaseous atom, right? The amount of energy that is required to knock out the outermost electron from the isolated gaseous atom is something which we call as ionization energy, right? Now there is a general trend which you all must be knowing. On moving along the period from left to right, what happens to ionization energy? Ionization energy increases generally on moving left to right, okay? And on moving down the group in your periodic table, what happens to the ionization energy? Ionization energy decreases down the group, generally, right? This is the general order, correct? Now, see, in the first option, we are given with lithium and beryllium, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. They belong to the same period, right? As I told you, on moving left to right, what happens to ionization energy? Ionization energy increases. That means ionization energy of lithium is going to be less than that of beryllium, right? Ionization energy of lithium is going to be less than that of ionization energy of beryllium. So first one is correct. But do I need to find the correct one or incorrect one? I need to find the incorrect one among all, right? Now people, if you look at the second option, it's given that ionization energy of beryllium is less than that of boron. Let's check it out. Let's check it out, understand? See, on moving from beryllium to boron, what should happen to the ionization energy? Ionization energy should increase. So what is the expected order of the ionization energies? I must say, ionization energy of boron should be greater than that of ionization energy of beryllium, right? This is the expected order. This is the expected order. But what is the actual order? Actual order is like this. Ionization energy of beryllium is greater than that of boron. This is the actual order. This is the exception over here, right? And what is the reason for this exception? Understand. If you look at the electronic configuration of beryllium, right? The outermost electronic configuration, it's going to be 2s2. If you look at the outermost electronic configuration of boron, it's going to be 2p1, right? Let me make it exactly. This is 2s2 configuration, the 2s2 outermost configuration of beryllium, 2p1 outermost electronic configuration of boron, right? So in order to take the electron out from this configuration and in order to take the electron out from this configuration, where do we need to supply more energy? This is more stable electronic configuration. This is completely filled orbital right here. This is more stable. So I must say the electron which is needed to, the energy which is needed to knock out this electron from this outermost configuration will be definitely more than that of this one, right? Because this is the stable electronic configuration. If it is a stable electronic configuration, it's completely paired electronic configuration. So you need to supply more energy, right? So electronic configuration of, the ionization energy of beryllium is absolutely going to be more than that of boron, right? What is mentioned over here? Ionization energy of beryllium is less than that of boron. Is this right or wrong? This is absolutely wrong. And we were supposed to check the incorrect statement. So second is going to be the incorrect among all, right? You can let me know in the chat box fast. You can let me know in the chat box fast if it is clear to everyone so that I can move on to the next one. Yeah. So remember this question. This question is frequently asked nowadays in your exams, right? Let me know fast in the chat box. Let me know fast in the chat box if it is clear to everyone so that I can move on to the next one, right? Perfecto, guys. Wonderful. Let's move on directly to one more question, yeah? Okay. Carnallite is a mineral of. Carnallite is a mineral of. Carnallite is a double salt first of all, right? Carnallite is a double salt first of all. It is a mineral of. First of all, you must remember the formula for this carnallite, right? Let me tell you, this carnallite is basically, it's KCl dot MgCl2 dot 6 times H2O, right? This is something which we call as carnallite. This is a double salt as well, right? Okay, now let me know fast in the chat box. This carnallite is a mineral of. It is a mineral of. Is it going to be the mineral of calcium? No, no way. Is it going to be the mineral of sodium? No way. Is it going to be the mineral of magnesium? Absolutely, it's going to be the mineral of magnesium. So option C is the one which is correct among all. You can let me know in the chat box if it is clear to everyone. Yes, exactly, VSK, you're right. Absolutely. Yes, carnallite is basically the mineral of magnesium, yeah? Perfecto, guys, wonderful. Let's move on directly to one more question then, yeah? Let's move on to one more question. Okay, the bond order of NO molecule is, what do you think is the bond order of NO molecule? Give it a try and let me know its answer fast, yeah? The bond order of NO molecule is, let me know its answer fast. People are coming up with option C. Should I be believing you? Yes. Yes, Mohammad Arshid, nowadays this is the level of JEE Mains, right? These are NT equations, right? So this is going to be your level for JEE upcoming mains, right? Let me know fast. Well, people are coming up with option C. Absolutely, guys. Just remember one thing. See, if you talk about N2 molecule, if I talk about N2 molecule, how many total electrons are there in N2 molecule? There are 14 electrons. Any species, any molecule which will be having 14 electrons in it, its bond order is going to be 3. All of you must be knowing this, right? Its bond order is going to be 3. Any molecule which will be having 13 electrons in total will be having the bond order of 2.5. You can remember it like this as well. Similarly, any species which will be having the which will be having total 15 electrons in it, it is going to have the bond order of 2.5 as well. Okay, you can remember it like this. Or if you don't want to remember this, then it's time to write the molecular orbital electronic configuration, right? Once you write the molecular orbital configuration, after that you'll be calculating the bond order by the formula half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. Well, people, if I talk about the NO molecule, which has got total 13 electrons in it, let me try to distribute these electrons in this molecular orbital configuration. It's going to be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2p z2, similarly sigma 2p x2, this is pi 2p x2, pi 2p y2, pi star 2p x1, and pi star 2p y0, right? So now I'll be counting how many electrons are there in bonding molecular orbital. This bonding, so 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, right? So 10 electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital, 2, 2 to 4, 4, 1, 5. So 10 minus 5 is 5, 5 divided by 2 is 2.5. So remember this molecular orbital configuration, you can easily solve these sort of questions, I'm sure about it, right? Okay, perfecto, guys. So is it clear to everyone? Should I be moving on to the next one? Or remember it like this, N2 molecule with the total electrons as 14 will always have the bond order 3. Any species which will be having 14 electrons will have bond order 3. Any species which will be having 13 electrons will be having bond order 2.5. Any species which will be having the total electrons as 15 will have bond order 2.5 again, yeah? Perfect to everyone? Let me know fast if it is clear to everyone. Yes? Wonderful, guys. If you have not liked the video, please do like the video and share the video with your friends so that everyone gets benefited out of these sessions, yeah? Perfecto, guys. Let's move on directly to one more question which is going to be on your screen. Okay, this is the question from the chapter solutions. Give it a try and let me know its answer first. Well, people, as per the question, equal volumes of 0.1 molar NaCl and 0.06 molar CaCl2 solutions are separated by a semi-permeable membrane in a container. For this system, the correct statement is: water flows from NaCl solution towards CaCl2 solution. There is no movement of any solution across the membrane. Osmotic pressure of 0.1 molar NaCl is less than the osmotic pressure of CaCl2. Water flows from CaCl2 solution towards the NaCl solution. Can you let me know its answer fast in the chat box? Let me know its answer fast in the chat box. Guys, tomorrow at 11:30 a.m. in the morning, I'm starting a session, right? That is going to be the complete revision of your entire chemistry for the JEE 2021. The session will be definitely for more than 5 hours. I want every one of you to be there on time at 11:30 sharp, right? It's going to be the complete revision of chemistry. Perfect, guys. So how do we solve this sort of equation? Understand properly. We have got two solutions, right? We have got two solutions. So let me take a bigger container like this. Let me divide this container into two equal parts by means of a semi-permeable membrane. Yes, I've divided this container into two equal parts. Yeah, in one part of the container, I've got NaCl solution. In the another part of the container, I've got CaCl2 solution, right? First of all, before doing anything, right, we know your NaCl as well as CaCl2, these are strong electrolytes, so definitely they will be getting dissociated completely into its ions, right? So if I talk about NaCl, NaCl would have got dissociated as Na positive plus Cl negative, right? And similarly, your CaCl2, it would have got dissociated as Ca di positive plus 2 times Cl negative, right? So if I'll ask you what is the Van 't Hoff factor for NaCl, you can clearly say one particle of NaCl is giving me 1 plus 1, 2 particles, right? So Van 't Hoff factor is 2. What is the Van 't Hoff factor for CaCl2? Have a look. One particle of CaCl2 is giving me 1 plus 2. That means 3 particles. So Van 't Hoff factor over here is 3. So Van 't Hoff factor for NaCl is 2 and Van 't Hoff factor for CaCl2 is 3, correct? Now, understand. Let me calculate the osmotic pressure of NaCl, okay? People, I hope you remember the formula to calculate the osmotic pressure. Pi is equal to I CRT, where C is the concentration, right? Okay. So osmotic pressure of NaCl, if I'll calculate for NaCl, I'm writing it as for NaCl. If I'll be calculating the osmotic pressure for NaCl solution, it's going to be I value for NaCl is 2, right? Concentration of NaCl is 0.1. So 2 multiplied by 0.1 is 0.2. It's going to be 0.2 RT. This is the osmotic pressure of NaCl solution, 0.2 RT, right? This is the osmotic pressure of NaCl solution. What about the osmotic pressure of CaCl2 solution? I'm writing it somewhere over here. For CaCl2 solution, the osmotic pressure pi will be equal to I, Van 't Hoff factor, that is 3, multiplied by concentration of CaCl2, that is 0.6. So 3 multiplied by 0.6 comes out to be 0.18. So it's going to be 0.18 RT. This 0.18 RT is the osmotic pressure of CaCl2 solution. Okay. Now I need to see the moment of solvent molecules. Moment of solvent molecules will be absolutely from lower osmotic pressure to higher osmotic pressure, right? Okay. Is that? Can you let me know what is going to be the answer of this question first? Can you let me know? Well, we got to know. This is the osmotic pressure of NaCl. This is the osmotic pressure of CaCl2. Is it going to be option C or D? Absolutely, osmotic pressure of NaCl is greater than CaCl2. What is mentioned over here? Osmotic pressure of 0.1 molar NaCl is less than. No way. It's not going to be the answer, right? Okay. So the moment of water molecules will be absolutely from what? From where to where? It will be from CaCl2 solution towards NaCl solution, right? It will be from here to here, from lower osmotic pressure to higher osmotic pressure. Remember this from now onwards, correct? The moment of water molecules, the moment of solvent is going to be from the lower osmotic pressure side to the higher osmotic pressure side. That means CaCl2 side to the NaCl side. I'm sure it's clear to everyone, right? Okay. Perfect. You can let me know in the chat box if it's clear to everyone so that I can move on directly to one more question. Yeah. Let me know fast in the chat box if it's clear to everyone so that I can move on directly to one more question. Yeah. No, Mohammed Arshid, you cannot solve this question directly by having a look on molarity. No, you have to take into consideration the Van 't Hoff factor as well. Okay. Perfecto, guys. Let's move on directly to one more question which is on your screen. Arrange in the decreasing order of rate of electrophilic substitution. Yeah. Arrange the following in the decreasing order of the rate of electrophilic substitution. What do you think about this? Give it a try. What do you think about this? Give it a try. It's a very, very simple question again, yeah? Give it a try, guys. Rate of electrophilic substitution. What is an electrophile? Electrophile is something which we call as electron-loving species. Yes? Electron-loving species. So electrophile will attack faster at the place where the electron density will be maximum. Electrophile will be attacking faster at the place where the electron density will be maximum. Now I need to see in which of the ring electron density will be maximum. I need to see in which of the ring electron density will be maximum, right? See guys, this is the carbon which is attached with the benzene ring. This is the carbon which is attached with the benzene ring. This is the carbon which is attached with the benzene ring. This is the carbon which is attached with the benzene ring, right? Now we will understand. This is my alpha carbon. This is my alpha carbon over here. This is the alpha carbon. This is the alpha carbon. So first of all, over here, how many alpha hydrogens do we have? We have got 3 alpha hydrogens. How many alpha hydrogens do we have in this case? 1 alpha hydrogen. How many alpha hydrogens right here? 0 alpha hydrogens. How many alpha hydrogens right here? Let me know fast. How many alpha hydrogens? 2 alpha hydrogens, right? 2 alpha hydrogens, correct? Now people, first of all, can I say where the alpha hydrogens will be maximum? There only hyperconjugation plus H effect will be maximum, right? Okay. So hyperconjugation will be maximum in the first case, right? Yes, and it's going to be plus H effect. right? So electron density will be maximum in the first case, right? Followed by, electron density will be maximum in the first case, followed by the fourth one, followed by the second one, followed by the third one, right? Okay. And wherever electron density will be maximum, there only nucleophile will attack faster. So there only electrophile will attack faster, right? So rate of electrophilic substitution will be maximum in first, followed by fourth one, followed by second one, followed by third one. Which option satisfies it? 1, 4, 2, 3. 1, 4, 2, 3. Which option is it? 1, 4, 2, 3. Option 3 must be the answer of this question, right? Yes? Let me know fast in the chat box if it's clear. Yeah? So whenever you need to see the rate of electrophilic substitution, you need to see the electron density in the rings. Wherever electron density will be maximum, there only rate of electrophilic substitution is going to be maximum, right? And all these groups which are attached with the benzene rings, these are basically increasing the electron density in the benzene ring, right? Through plus H effect. Now wherever plus H effect will be maximum, there only rate of electrophilic substitution reaction will be maximum, yeah? Hero Gaming, this is the English channel. I'm not supposed to talk in Hindi, bro. Perfect, guys. I'm sure it's clear to everyone, right? Yes, Mohit, tomorrow 11:30 a.m. in the morning, I'm starting a revision of complete chemistry, okay? So that session which I'll be starting tomorrow at 11:30 is going to cover everything, yeah? Perfecto. Let's move on directly to one more question which is on your screen. Okay. Reaction of ester with Grignard's reagent gives rise to. Reaction of ester with Grignard's reagent gives rise to. What do you think about this? What do you think about this? Give it a try. Let me know its answer. That's great, Arshad. That's great. Well, people are coming up with the option B. Is that? People are coming with the option 1, option C, option 4. What is it? Reaction of ester with Grignard's reagent gives rise to. What do you think about this question? Yeah? Let's give it a try. Let's see how this question is to be solved. Well, people, as per me, it should be tertiary alcohol. As per me, it should be tertiary alcohol. Let me show you now how come it's going to be tertiary alcohol. Yeah? Reaction of ester. Let me take an ester over here. This R, C double bond O. This is O. Let me keep this as R dash. Okay? Just to differentiate this R and this R, right? Now, I'm making it to react with the Grignard's reagent, which is R. I'm making it as double dash so as to differentiate all the R's. It's going to be Mg. This is X, right? Okay. In your Grignard's reagent, this R carries the negative charge and this Mg carries the positive charge. We know it, correct? Now, what is going to happen first of all? What is going to happen first of all? Understand. This CO bond, it's a polar bond, right? So this bond is going to break in this direction. If the bond breaks in this direction, there will be negative charge on this oxygen, right? And this positive charge will be on the carbon. And on this positively charged carbon, this R negative is going to attack right here. Yes? So what do I get right here? I get something as this is R, this was C, this was O with a negative charge, and this O negative now it's going to attract this Mgx positive towards itself. This is Mgx positive, correct? And over here there was OR dash attached already, and now there comes R double dash as well. Now there comes R double dash as well, correct? This is something which I got in the first step. Now we will understand. This is a negative charge on oxygen. This negative charge, it can participate in the resonance, right? This negative charge again comes here, right, in the form of a double bond. This OR dash, it is a good leaving group. It leaves as OR dash negative. Okay, so what do I get now again? I get something as this is R, this is C. Now again, it's a double bond O, right? This is your R double dash, which was attached as such, yes. And with this OR dash, it leaves as OR dash negative. And with that OR dash negative, this MgX gets attached, right? Yes. So you get R dash O, this is MgX. You got something like this, yeah? Now people, this substance which I got, now the hydrolysis of it will happen, right? It is what we call as acidic hydrolysis. Due to which, what is going to happen? Your RMgX, which I'm representing as R double dash MgX, right? Right, your Grignard's reagent. Again, it's going to attack at this. Okay, how it's going to attack? See, on R you have got the negative charge, on Mg you have got the positive charge. This bond will again break in this direction, and this R negative will be attacking at this carbon because deficiency got created over here. Yes, so what do I get? You get something as R, this is C, right? Wait guys, this is not hydrolysis, sorry. Again, your Grignard's reagent is going to attack over here. It's going to be R, and this is going to be C, O. On oxygen, there's a negative charge, right? On oxygen, there's a negative charge. Already there was R double dash. Already there was R double dash, correct? Now, this R, let me keep this as triple dash, for example, so as to differentiate everything. Let's keep this as R triple dash or R double dash only, correct? This is going to attack at this position. Okay, now at this O negative, what comes? This Mg positive X comes with this Mg positive X, correct? Now, people, after this, what is going to happen? Hydrolysis is going to happen, right? H2O in presence of H positive. Now, what you are going to do is, this MgX will leave with OH negative, and you get something again as what? You get something as alcohol over here, right? You get R, this is C, this is OH over here, right? This is your R double dash, this is your R triple dash over here. Sorry, double dash, this is triple dash, correct? So this is the final product which you got, correct? Which is basically the tertiary alcohol over here, right? So which option is the correct one? So tertiary alcohol gets formed in this case, and this is the mechanism of it. You can remember it from now onwards, yeah? Okay. People, is it clear to everyone? Let me know fast. Let me know fast, let me know fast. Let me know fast. Is it clear to everyone so that I can move on to the next one? Yeah? Mechanism is not important. Just remember it like this. Whenever ester reacts with Grignard's reagent, what do you get? You get tertiary alcohol. Just remember it as simple as that, yeah? Okay. Perfect, guys. Let's move on to one more question then, yeah? The percentage of oxygen in CH2O will be. What do you think about this? The percentage of oxygen. I need to calculate the percentage of oxygen, yeah? The percentage of oxygen in CH2O will be. Percentage of oxygen in CH2O will be. First of all, what is the molar mass of oxygen? That's 16, right? Divided by. What is the molar mass of this whole compound? Carbon, it's 12, right? Hydrogen, it's 1 multiplied by 2. Oxygen, it's 16. So 12 plus 2 comes out to be 14. 14 plus 16 comes out to be 30 multiplied by 100, right? Get the value? This is going to be the percentage of oxygen in CH2O, right? As simple as that, right? The basic equation this is, correct? Okay, so you get the value finally as 53.33% over here. Exactly, guys. So option C is the one which is correct among all. I'm sure it's clear to everyone. I'm directly moving on to one more question. Okay, the question from thermodynamics part. Again, a simple question, and these sort of questions are directly asked nowadays in your examinations, yeah? See, guys, how this question is to be solved. An ideal gas is taken around the cycle ABCA. Okay, we are taking the ideal gas along the cycle ABCA, right? What is this ABCA? Yeah, okay, ABCA, like this. Okay, this is the cycle which is what we have. The net work done by the gas during the cycle. We are supposed to calculate the net work done, right? Well, it's a cyclic process, and in the cyclic process, net work done is equal to the area enclosed by the loop. I hope you remember this. Area enclosed by the loop. And area enclosed by the loop, that means this area I'm talking about, right? Area enclosed by this triangle, it's going to be half of base into height, half of AC multiplied by AB, right? Okay, so it's going to be half of AC, right? AC means from here to here. From here to here, it's going to be 3V1 minus V1. So from here to here, it's going to be 2 times V1, correct? It's going to be 2 times V1 multiplied by AB. AB means from here to here, it's going to be 4P1 minus P1. That means 3P1, correct? So the value will be simply 3 times P1 V1. This is the net work done during this cycle. So option C is the one which is correct among all. You can let me know in the chat box if every single thing is clear till here so that I can move on to the next one, yeah? Exactly, guys, it's going to be option C, right? Simple, whenever you are given with the cyclic process, in the cyclic process, whatever is the area enclosed by the loop, that area enclosed by the loop exactly gives you the magnitude of the work done, right? That gives you the magnitude of net work done, right? Okay, perfect. Exactly, Jagdish, but these are the JEE mains level questions these nowadays, yeah? Okay, because these are NTA questions, because from NTA you get the clear-cut idea of what is going to be your JEE mains level in the coming attempt, right? So make sure, I mean, remember this is going to be your level of the examination. Yes, Sai Teja, I'm from Srinagar. I'm live right now from Srinagar, Jammu and Kashmir. Perfect, guys. Let's move on to one more question. The solubility of the fluorides of alkali metals in water is, okay? Just give it a try. Let me know fast. Let me know fast. Give it a try. Let me know fast. The solubility of fluorides of alkali metals in water is. The solubility of fluorides of alkali metals in water will be. What do you think about this? What do you think about this? Yes, Swaroop, this is going to be your actual level of JEE Mains this time, okay? Because these are NT equations. Okay, let me tell you first of all, your solubility of fluorides of alkali metals, it's inversely proportional to the lattice energy of these fluorides of alkali metals. Inversely proportional to the lattice energy of these fluorides of alkali metals, right? Now, what all fluorides we are given with? We are given with lithium fluoride, right? We are given with sodium fluoride. We are given with potassium fluoride. We are given with rubidium fluoride. We are given with cesium fluoride, right? These are the fluorides which I'm given with. So wherever lattice energy will be maximum, there only solubility will be minimum, right? In water. Now, your lattice energy, it is directly proportional to the charge present on the ions and inversely proportional to the size of the ions, right? Since charge present on every ion right here is same, charge present on every ion right here is same, so I'm not going to decide on the basis of charge, it's time to decide on the basis of size. Wherever size is minimum, size of ions is minimum in the first case, right? Size of anion is same in all the cases. Now let's talk about the size of cation. Size of cation is minimum in the first one. If the size is minimum, that means lattice energy of the first one is maximum. If the lattice energy of first one is maximum, that means lattice solubility of the first one will be minimum, right? So solubility of lithium fluoride is minimum, and as I'll be moving down the group, so it will keep on increasing. Yes, okay. So what is going to be the order? CSF will have maximum solubility, followed by RBF, followed by KF, followed by NAF, followed by LIF. So option 2 is the one which is correct among all. Correct? You can let me know in the chat box, and do not forget to hit the like button, and do not forget to subscribe to the channel as well, if it is clear to everyone. Yeah? Let me know fast. Let me know fast. Yes? All right, guys. Wonderful. So I'm sure it's clear to everyone, right? Let's move on to one more question then, which is again from thermodynamics. Which of the following pairs of chemical reaction is certain to result in a spontaneous reaction? Okay, what do you think about this question? Give it a try. Give it a try. Let me know fast. Let me know fast. It's again a very simple question. Okay. Right? What do you need to check basically? Which of the following pairs of chemical reactions is certain to result in a spontaneous reaction? Right? For the reaction to be spontaneous, right? For the reaction to be spontaneous always, what are the conditions for it? Yeah? See guys, first thing, as you all must be knowing now, for the process to be spontaneous, delta G of the system at constant pressure and temperature, it must be negative, right? Delta G, as you all must be knowing, that's basically equal to delta H minus T delta S. So this value should be negative. When can be this value negative? When can be this value negative? This value will be always negative if delta H will be negative and delta S will be positive, right? This delta G will be always negative if delta H is negative and delta S will be positive. For which reactions delta H is negative? These are going to be exothermic reactions. In case of exothermic reactions, delta H is negative, right? And for any system, if delta S is positive, what does that mean? That means entropy of the system is increasing. That means entropy of the system is increasing, right? So for the system, for the chemical reaction, for the reaction whose entropy will be increasing with time, and at the same time, which is going to be exothermic in nature, that reaction will have always delta S as negative, right? And if the delta S for the reaction will be always negative, that means that reaction will be always a spontaneous reaction. Okay, so it's going to be exothermic and increasing disorder. Yeah, exothermic and increasing disorder. So it's going to be option 1, which is correct among all. I'm sure it's clear to everyone. You can let me know in the chat box fast if you want me to move on to the next one, right? Aditya, you cannot solve that question by the formula because you were not given with the temperature and all the parameters, right? So you have to use the concept of the area enclosed by the loop. Perfect. Wonderful, guys. Let's move on directly to one more question then. I'm sure it's clear to everyone, yeah? Okay, the wave number in centimeter inverse of the first line in the atomic spectrum of hydrogen in Balmer series. First line of Balmer series. What is Balmer series basically? In the Balmer series, the electron makes a transition from higher energy states to shell number 2, right? From higher energy states to shell number 2. Higher energy state is represented by N2. Now, if I talk about the first line of Balmer series, first line of Balmer series means that's also called as H alpha line of Balmer series, in which the electron makes a transition from 3 to 2. This is the higher energy state 3, this is the low energy state 2, right? Now, I'll be using the Rydberg's formula. Wave number is basically equal to R Z square. Z is basically the atomic number of hydrogen, that's 1 divided by N1 square. 1 divided by N1 square, which is 2 ka square, that's 4, minus 1 upon N2 square, which is 3 ka square, that's 9. So you get the wave number simply as R. It's going to be 5 divided by 36, right? So you get the wave number as 5R divided by 36 centimeter inverse. 5R divided by 36 centimeter inverse. This is going to be the answer of the question, right? As simple as that. Let me know fast in the chat box if it's clear to everyone so that I can move on to the next one. Absolutely, guys, it's going to be 5R divided by 36, right? Just the formula, just the Rydberg's formula I used. Let me give the Rydberg's formula again. Wave number, which is basically equal to 1 divided by lambda, is equal to R Z square multiplied by 1 upon N1 square minus 1 upon N2 square, right? Okay, this is the Rydberg's formula. Correct? And at the same time, remember, 1 divided by R value you'll be always taking as 911.5 angstroms. Then only you can reduce your calculation time. Okay? I'm sure it's clear to everyone, right? Let's move on directly to one more question. This is one more question. In the following reaction, right, your acetyl chloride in presence of H2 PDBaSO4 gives X. This X is, it's a very, very common reaction, guys. It's a very, very common reaction, right? This reaction is what we call as Rosenmund's reduction, right? And from acetyl chloride, what do we get? We get the alkyl, we get the aldehyde, sorry. We get the acetaldehyde, right? By the reduction of acetyl chloride through Rosenmund's reduction, what do we get as the product? We get the acetaldehyde as the product, right? All of you must be knowing this reaction. It's a very, very common reaction. A Rosenmund's reduction reaction from acetyl chloride, what do we get? We get the acetaldehyde, right? So from acetyl chloride, you are getting acetaldehyde in presence of what? H2 PDBaSO4. This is what we call as Rosenmund's reduction, correct? Joy, if you are not clear with the last question, let me tell you first of all. If I talk about the first line of Lyman series, in first line of Lyman series, electron makes a transition from 2 to 1. If I talk about the first line of Balmer series, electron makes a transition from 3 to 2. If I talk about the first line of Paschen series, electron makes a transition from 4 to 3, right? And first lines of series are what we call as H alpha lines as well, yeah? So you can remember it that way as well. Yes, Sanjay, names are important. Absolutely, names are important, yeah. Perfect, guys, okay. Among the following, the number of aromatic compounds will be. First of all, what are the conditions which a molecule must satisfy? Then only we can call it aromatic. What are those conditions? What are the conditions which a molecule must follow so as to call it as aromatic? First of all, let me tell you those conditions, then only we'll be solving this question. For the molecule to be aromatic or anti-aromatic. For the molecule to be aromatic or anti-aromatic, the molecule must be cyclic. Condition valid for both. Molecule must be cyclic. There should be complete cyclic conjugation. Right? Okay. And for the molecule to be aromatic, it should follow the Huckel's rule. There should be 4n plus 2 pi electrons involved in the complete cyclic conjugation. And for the molecule to be aromatic, there should be 4n pi electrons involved in the complete cyclic conjugation. Right? Okay. And remember, for the molecule to be aromatic, anti-aromatic, it should be cyclic, complete cyclic conjugation, or you can say every atom should be sp2 hybridized, okay, for the molecule to be aromatic or anti-aromatic, right? Only this Huckel's rule, it differentiates your aromatic and anti-aromatic compounds, right? See, this is sp2, this is sp2, this is sp2, and it's cyclic at the same time, right? How many pi electrons are involved in the complete cyclic conjugation? So this is basically, this negative charge is in resonance, is in conjugation with this pi bond, so 2 to 4. So there are 4 pi electrons involved in this complete cyclic conjugation, so it's going to be anti-aromatic, right? Now we will have a look. sp2, sp2, sp2. Only 2 pi electrons we have involved in complete cyclic conjugation, right? So 2 pi electrons means aromatic, so this is aromatic. right? Okay, if I talk about this one, this is sp3, this is sp3. It is non-aromatic. Okay, it is non-aromatic because sp3, correct? Similarly, if I talk about this molecule, sp2 everywhere, 2, 4, 6, 6 pi electrons following the Huckel's rule, that means it's aromatic, right? What about this one? sp2, 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 right? 2, 4, 6. Okay, so 6 pi electrons involved in complete cyclic conjugation, so aromatic, yeah? What about this one? What about this one? It's again going to be, see, every atom over here is sp2 hybridized and it's a complete cyclic conjugation, so 2, 4, 6, 8, 10, right? So 10 pi electrons means it's following the Huckel's rule, so aromatic, right? What about this one? Okay, see, this ring is been, I mean, if I'll make its conjugate, if I'll make its one more resonating form, from that resonating form, you can clearly say whether it's going to be aromatic or anti-aromatic. See how I'm going to make that. Understand this in detail a bit. Okay, understand this a bit more in detail. See guys, if I'll make the one more resonating structure of this, it's going to be like this. Okay, it's going to be like this. Just a second, this will be a double bond here, this will be a double bond here, right? If here is a double bond, here is going to be a double bond, here is going to be a double bond. See, these two are basically resonating structures of each other. Now let me tell you, aromatic ring plus aromatic ring, it makes the overall molecule as aromatic. Aromatic plus anti-aromatic makes the overall molecule as anti-aromatic, right? Now see, this ring is aromatic, this ring is aromatic, this ring is aromatic. So aromatic plus aromatic plus aromatic, this molecule is going to be aromatic, right? Now the equation is done and dusted. You can clearly say how many molecules are following the Huckel's rule, right? So see, this one is aromatic, this one is aromatic, this one is aromatic, right? This one is aromatic, and at the same time, this one is aromatic, and at the same time, this one is also aromatic. So how many aromatic molecules do we have? 1, 2, 3, 4, 5. So there are 5 aromatic molecules. So option C is the one which is going to be correct among all, right? So there are basically 5 aromatic molecules among the all. I'm sure it's clear to everyone. Yes? Okay, perfect guys. Let's move on to one more. The combustion of sodium in excess air yields a higher oxide. What is the oxidation state of oxygen in the product? Sodium in excess of oxygen, it forms sodium peroxide or sodium superoxide. What do you think? Sodium in excess of oxygen, right? It forms sodium peroxide, right? And in case of sodium peroxide, Na2O2. In case of sodium peroxide, so in this reaction, what we will be getting? We'll be getting the sodium peroxide, Na2O2. And what is the oxidation state of oxygen in case of product? In case of peroxides, the oxidation state of oxygen is always going to be -1, right? So option C is the one which is correct among all. Absolutely. Is it clear? Yes? I'm sure it's clear to everyone, right? Perfecto, guys. Let's move on to one more question then. Okay. Which curve represents zero order reaction? A very simple basic equation, right? For the zero order reaction, if you remember the integrated rate equation, that's basically going to be equal to concentration of A left at any time t, I mean the concentration of reactant at any time t is basically equal to A naught minus KT. This is basically the integrated rate equation for the zero order reaction, right? Now basically I'm plotting a curve between A versus T, right? So A versus T, is it going to be in the form of Y is equal to minus mx plus C type? Y is equal to minus mx plus C. That means slope is negative, intercept is positive. So this is the curve which will be the correct one among all, option C, right? Okay, Y is equal to minus mx plus C type. See, the integrated rate equation for the zero order reaction is going to be AT is equal to A naught minus KT, right? This is the integrated rate equation. You need to plot a curve between AT versus T. It's going to be Y is equal to minus mx plus C form. So it's going to be a straight line with a negative slope and the intercept is absolutely going to be positive, right? Yes? Perfect, guys. Let's move on directly to one more question then. I'm sure it's clear. Yeah? The correct IUPAC name of the following compound. What do you think about this one? Again, this question is something which all of you will be loving, I must say. Yeah? Right? Let me know fast. The correct IUPAC name of the following compound will be. What do you think about this question? The correct IUPAC name of the following compound will be. Yes, Arshid, in the tomorrow session, which I'll be starting at 11:30 in the morning, right? I'm going to do a complete revision of your chemistry. So do attend that session, which will be starting tomorrow at 11:30 a.m. in the morning. The session will be for more than 5 hours, right? I'll try to summarize your entire chemistry in that one shot, okay, in the form of questions. Yes? See guys, so if I'll ask you what is going to be the IUPAC name of the following, so first of all, have a look. Over here we have got a cyclic ring. Over here there's open chain on the another side, right? I need to see which parent chain is going to contain maximum number of carbon atoms, right? This ring will have only 3 carbon atoms, correct? And this open chain, if I'll do, this is going to be 1, 2, this is 3, this is 4. So which open chain or cyclic, which is longer chain? Open chain is longer, so that's going to be my parent chain, right? This open chain is going to be my parent chain. So what is going to be the name of the compound? It's going to be 2-cyclopropyl, 3-methyl, 2-cyclopropyl, 3-methyl butane, right? Okay, now check the options. 2-cyclopropyl, 3-methyl butane, that means option 2 is the one which is correct among all, right? Yes? Rohit, tattva material is enough. It is enough. Absolutely it's enough, right? I'm sure it's clear to everyone now. Yes? Let's move on directly to one more question. The correct increasing order of ease of liquefaction, right? Ease of liquefaction basically depends on the value of compressibility factor. Lesser the compressibility factor, easier will be the liquefaction process, right? So let me tell you one simple thing which you are going to remember. Ease of liquefaction is inversely proportional to the value of Z. Less the value of Z, more will be easier will be the liquefaction process, right? Now I'm given with the curve for H2, N2, CH4 and CO2. I'm given with compressibility factor versus pressure curve. Now I'll be drawing a straight line, and along this line I'll be checking the Z values. Which one has the minimum Z value? Carbon dioxide has the minimum Z value. So carbon dioxide will be getting liquefied with a lot of ease, right? So what is going to be the ease of liquefaction? Absolutely carbon dioxide. Okay, we'll have the maximum ease of liquefaction, followed by CH4, followed by N2, followed by H2, right? So option 1 is the correct among all. Simple, check the Z value. Wherever you see the Z value as minimum, there only ease of liquefaction will be maximum. Z value is minimum in carbon dioxide, then Z value is minimum in CH4, then in N2, then in your H2. So wherever will be the Z value minimum, there only ease of liquefaction will be maximum. Remove this one at the same time, right? Perfect. Let's move on to one more question. The molar conductivity of 1.4 molar solution of an electrolyte is found out to be 138.9 Simon centimeter square per mole. Calculate the conductivity of the solution. What do you think about this question? Give it a try. Let me know its answer fast, yeah? Give it a try. There will be 30 mock tests, bro. Again, it's a very simple question, right? See guys, this question is all about the formula of molar conductivity. Molar conductivity formula, as you all must be knowing, lambda m is equal to kappa multiplied by 1000 divided by molarity of the solution, and its units right now are going to be in Simon centimeter square per mole, correct? So I'm going to use this formula, correct? But people, if you were given with the unit of lambda m as Simon meter square per mole, at that time this wouldn't have been the formula. The formula at that time would have been lambda m is equal to kappa divided by 1000 multiplied by molarity of the solution. This is the molar conductivity formula when you are supposed to calculate lambda m in Simon meter square per mole. This is the molar conductivity formula when you are supposed to calculate the molar conductivity in Simon centimeter square per mole, right? So right now I'm going to use the Simon centimeter square per mole wali formula. Lambda m, molar conductivity, it's given to me, I guess. It's 138.9. right, is equal to kappa we are supposed to calculate multiplied by 1000 divided by molarity of the solution is given to us, I believe. That's 1.5. So from here, can you calculate the kappa, where kappa is what we call as conductivity of the solution, right? A very simple and basic question, yeah? And the kappa value on solving, you'll be getting out to be 0.208 Simon centimeter inverse. Let me know in the chat box if it's clear to everyone so that I can move on directly to one more, yeah? Let me know fast, let me know fast. Let me know fast if it is clear to everyone so that I can move on to one more question, yeah? Let me know fast. Perfect, guys. Let's move on to one more. Okay. In the preparation of carboxylic acids from alcohols, which of the following reagent is not used? See, when we prepare carboxylic acids from alcohols, we need some oxidizing agents, right? Yes? Oxidizing agent is basically going to oxidize your alcohol, right? So in order to prepare your carboxylic acids from alcohols, we are supposed to make sure the alcohol reacts with the oxidizing agents like KMNO4, K2Cr2O7 and so on, right? So If I'll be using KMnO4, it's a strong oxidizing agent. It will convert your alcohol into carboxylic acid, definitely. This one will also. This one is also in the oxidizing agent. This one, LiAlH4, this is a reducing agent. This reducing agent is not going to convert your alcohol into carboxylic acid. Only oxidizing agent is the one which is going to convert your alcohol into carboxylic acid. So it's absolutely going to be your option D. Exactly, guys, you all are perfectly right. It's going to be option D, right? Perfecto. Let's move on to one more question then. Yeah? Okay, which one of the following two substances undergoes SN1 reaction faster? Wherein SN1 reaction will be faster? First of all, you must be knowing SN1 reaction, it gets complete in 3 steps, in which the first step, that is the ionization step, which leads to the formation of carbocation. That is the rate determining step. So wherever carbocation is the stable, remember, there only rate towards SN1 will be faster. So see, if you'll break this bond, there'll be a carbocation over here. Break this bond, carbocation over here. This is a 3-degree carbocation. It is a 2-degree carbocation. 3-degree carbocation is more stable. So this substrate is more reactive towards SN1 reactions, right? So it's absolutely going to be 1. 1 will react at faster rate than 2 towards SN1 mechanism, right? Okay, because in the first one, you are getting 3-degree carbocation, which is more stable, correct? Exactly, guys, perfect. Let's move on to one more question then. Okay, the percentage of p character in the orbitals forming pp bonds in P4 is P4, okay? First of all, you must know how this P4 looks like. This is P, this is one more P, this is one more P, just join these two, keep one P in the middle and join every P with this, right? On every phosphorus, you have got a lone pair as well. On every phosphorus, remember, you have got a lone pair as well. Just calculate the steric number of one of the phosphorus. It's forming 3 sigma bonds and 1 lone pair. 3 sigma bonds plus 1 lone pair. Steric number is 4. Steric number 4 means sp3 hybridization. If it is sp3 hybridization, what is the percent p character? Do we need to calculate p character? Yes. Yes, exactly. Percent p character is going to be equal. We have got 3 p's divided by total. We have got 3 plus 1, 4 multiplied by 100. The value comes out to be 75%, right? So 75% is basically the percentage p character in case of P4 in the orbitals pp, right? Exactly. Every phosphorus is sp3 hybridized. sp3 hybridized means the p character is 75 and the s character is 25%, yeah? I'm sure it's clear to everyone. So 75 is going to be the answer of this question. Yes. In forming P4 molecules, P uses sp3 hybrid orbitals. Therefore, P character in the hybrid orbital is 75% and S character is 25%. Clear to everyone? Yeah? Perfect, guys. Let's move on to one more. Okay. The question is from your chemical equilibrium. I'm given with 2 reactions. The value of K3 for the below reaction is A into 10 raised power minus 5. Determine A. Okay. Perfect. See, guys, what this question says. Basically, for this reaction, I need to calculate the equilibrium constant, which I'm representing by K3, right? Okay, and K3, as per the question, it's A multiplied by 10 raised power minus 5. I need to get this value of A. I need to get this value of A. See, how do I solve this? First of all, I need to make this reaction, right? I need to make this reaction from the given reactions. From the given reactions, I need to make this reaction. Okay. Now, how do I be making this? First of all, I'll be doing a simple thing. What I'll be doing is, I'll just reverse the first reaction. If I'll reverse the first reaction, it becomes P2 plus Q2 in equilibrium with 2 times PQ, right? Now, if I'll ask you, what is going to be the equilibrium constant of this reaction now? I will reverse the reaction, equilibrium constant gets inversed, it's going to be 1 divided by K1, right? Now, if I multiply this reaction by 1 by 2, it's going to be 1 by 2, this is going to be 1 by 2, this is going to be 2 gets cancelled out, so it becomes only PQ. So on multiplying the reaction by 1 by 2, that 1 by 2 goes to the power of equilibrium constant, which you all must be knowing, right? Okay. Now, people, let me just do one thing. Let me just, what do I need to write? Okay, let me just add this reaction and this reaction. If I'll add these 2 reactions, okay, let me write that reaction again. It is PQ plus half of R2, is that? It's in equilibrium with what? It's in equilibrium with PQR, correct? Its equilibrium constant is K2, correct? I'll simply add these 2 reactions. On adding these 2 reactions, this and this got cancelled out. So I get something as 1 by 2 P2 plus 1 by 2 Q2 plus 1 by 2 R2 is basically in equilibrium with PQR, right? And since I've added these 2 reactions, their equilibrium constants will be multiplied. So what is the net equilibrium constant of this reaction? It's going to be K2 multiplied by 1 divided by K1 raised power 1 by 2, right? This is going to be the equilibrium constant of this reaction, which we were supposed to calculate, right? Now, K2 value is given. K1 is given. This is basically K3. Put the value of K2 over here. K2 is given to me. Put the value of K1 over here. K1 is also given to me, right? Solve it. Get the value of K3, right? The equation is very, very, very simple. So you get the value over here as 1 into 10 raised power minus 5. So this 1 into 10 raised power minus 5 and compare it with A into 10 raised power minus 5. So A value you are coming from here as 1, right? You are getting from here as 1. Yes? Right? I'm sure it's clear to everyone, right? Perfecto. Let's move on to one more question then. In XeOF4, how many angles are of 90 degree? What do you think about this one? How many angles are of 90 degree in case of XeOF4? In case of XeOF4, 5 sigma bonds, 1 lone pair. 5 sigma bonds, 1 lone pair. 5 sigma bonds, 1 lone pair, right? It is XeOF4, correct? This is fluorine. This is fluorine. This is one more fluorine. This is one more fluorine, right? XeOF4. This is a double bonded O, and over here there's a lone pair. This is XeOF4 basically. So how many 90 degrees we have? Let me tell you, it's a tricky question. There is no 90 degree over here. There is 0 90 degrees over here. Why? Because of this lone pair bond pair repulsions. Due to these lone pair bond pair repulsions, the angles won't be 90 degree now. Okay? Remember, there will be 0 90 degrees in case of XeOF4. Remember it from now onwards. This is something which I want all of you to take a note of. Yeah? This question has never asked in your JEE examination. So keep an eye on this. Yeah? Perfect. If 3 moles of zinc is added to 0.52 moles of HCl, how many moles of H2 is produced? The question is based on the limiting reagent. The question is based on the limiting reagent. See guys how to approach to this sort of equation. Understand? At time t is equal to 0, when the reaction has not started, how many moles of zinc are we given with? We are given with 0.3 moles of zinc. How many moles of HCl are we given with? We are given with 0.52 moles of HCl. So this is going to be 0. This is going to be 0 because the reaction has not started yet, right? Because the reaction has not started yet. Now people, whenever you'll be given with the amounts of all the reactants, at that time I'll be using the concept of limiting reagent. Now the first thing which I'll do in the limiting reagent concept is I'll try to balance the reaction, and the reaction is automatically it's already balanced, right? After balancing the reaction, what I need to do is I need to check which one is the limiting reagent among the 2 reactants. How do we check the limiting reagent? Just divide the given moles by their respective stoichiometric coefficient. So 0.52 divided by 2. This is going to be 0.3 divided by 1. This value will be 0.26, and 0.26 is less than 0.3. So this HCl is your limiting reagent. Since you have identified which one is the limiting reagent, we know limiting reagent is the one which gets completely consumed in the reaction. So after some time, right, when the reaction will stop, at that time, you will see there will be 0 moles of HCl left in the container. Now I need to calculate what? I need to calculate moles of H2 formed. Remember, entire product gets formed on the basis of the limiting reagent. I'll clearly use the stoichiometry. I'll say 2 moles of the limiting reagent gives 1 mole of H2. So 1 mole of limiting reagent gives 1 by 2 moles of it. So 0.52 moles will give 1 by 2 multiplied by 0.52. Value will come out to be 0.26. So 0.26 moles of H2 will be formed at the end of the reaction, which I was supposed to calculate, right? Okay. Just the limiting reagent concept, guys. That's it. See, I identified which one is the limiting reagent. Now entire product is decided. Entire product is governed by the limiting reagent, right? Okay, I can see 2 moles gives 1 mole, 1 mole gives 1 by 2, 0.52 gives 0.26 moles of H2. As simple as that, yeah? Right? Correct? Perfect, guys. Let's move on to one more question then. Let's see if we have more questions or not. Yes. In methylamine, okay, it's not methylamine, sorry. In melamine, the total number of nitrogen atoms having sp2 hybridization is. Melamine formula you should know, melamine structure you should know. Melamine formula is going to be C3H6N6, right? Yeah, C3H6N6 is going to be the formula of the melamine, right? So remember, this is the structure of melamine, C3H6N6, this is the formula, right? This is the structure. You need to remember the structure because from the in the last session, I mean when I took the last mock test, in that there was a question based on the melamine as well. So have a look on this melamine properly. Okay, I hope you get it. In the melamine, the total number of nitrogen atoms having sp2 hybridization. Okay, understand? sp2 hybridization. This nitrogen sp2, this is sp2, this is sp2. There is a lone pair on this nitrogen, lone pair on this nitrogen, lone pair on this nitrogen, right? This is sp3, this is sp3, this is sp3, and these threes are sp2, correct? So there are three nitrogens with the sp2 hybridization in case of the melamine, right? I'm sure it's clear to everyone. I think this was the last question, absolutely. So we are done with the 12th mock test. I'm sure it was clear to everyone. People, before ending the session, let me tell you one important thing. Okay? What is that? Tomorrow at 11:30 a.m. in the morning, I'm starting a session which is going to be complete revision of your chemistry. Complete chemistry revision, right? The session will be 5+ hours, right? Its duration will be 5+ hours. So do join the session. I'll be doing basically the revision of entire chemistry in the form of some important questions, important concepts, right? I'll try to summarize your entire chemistry in the tomorrow's session, right? Yes? Okay, so do join me on the same channel tomorrow at 11:30 a.m. in the morning, right? We can start at 11:30 a.m. We can finish it by 7 p.m., right? Let's keep this as the duration of the tomorrow session, right? Anshul, you can join in. You can join in tomorrow, correct? And the those people among you who think your preparation is not up to the mark, people, we have got one best plan for you. In these like 10-15 days, we are starting a small crash course, and in that crash course, right, all the major concepts of physics, chemistry, as well as mathematics will be getting revised on the actual on the platform, on the teachers of, by the teachers of our choice, the best, the killer, the experienced teachers of your physics, chemistry mains, physics, chemistry, maths, who will be taking care of this crash course in just 15 days, right? Session frequency will be high, right? But at the same time, your course completely will be getting covered with your test series, with your mock test, everything. So if you think your preparation is not up to the mark right now, do get enrolled in this crash course, right? And this crash course, let me tell you, it covers your entire physics, chemistry, maths. At the same time, no need to worry about the test series, no need to worry about the mock test, everything is included. And at the same time, this crash course, if you are using this coupon code as WSCC, on using this coupon code as WSCC, you are just getting this crash course for 4K. Do get enrolled in this as soon as possible, because it's highly beneficial for you right now, okay? So do get enrolled, and do not forget to use the coupon code as WSCC. Link is there in the description box of the video, okay? There is one more link in the description box, that's for the Telegram. Do click on the link, get added to the Telegram group, and stay updated about the classes. And the ones who have not liked the video yet, please do like the video. Share the video with your friends, and do not forget to subscribe to the channel as well, and do not forget to hit the bell icon so that you get the notification of every single session which will be taking live on this JEE Enthuse channel, yeah? So I'll see you guys tomorrow at 11:30 a.m. sharp in the morning, right? Till then, you guys take care. Bye-bye. God bless you all. Love you all. See you tomorrow. Bye guys. Take care.